we can just make the data at the high resolution available into much broader scale and into much broader use cases where we can lower the cost of the data significantly, almost by an order of magnitude. So it can be used in various different areas that it wasn't feasible just with the multicopters or the traditional drones.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 408. Is there an easier way to scale aerial data collection? For that question, we head to Finland to speak with Janne Hietala, a technology enthusiast and CEO of Kelluu. Kelluu designs, manufactures, and operates intelligent airships for persistent aerial monitoring. The company's fleet of hydrogen-powered vehicles, capable of staying airborne for 12 hours, is equipped with an array of spectral cameras, sensors, and scanners. These instruments can gather real-time data on a diverse range of subjects, including terrain, vegetation, and infrastructure. Janne's journey in entrepreneurship is noteworthy, with achievements such as bootstrapping a software company to a remarkable 15 million euros in revenue, managing a team of 250 professionals across 7 countries, and ultimately exiting the venture in 2021. His achievements were recognized in 2012 when he was honored with the prestigious Young Entrepreneur of the Year award. Founded in 2018, under Janne's leadership, Kelluu has swiftly established itself as a key player in the creation of digital twins, catering to various applications and industries. In this episode of the Drone Radio Show, Janne shares his insights on how Kelluu's innovative hydrogen-powered airships are poised to revolutionize the way we approach aerial data collection, offering scalability and efficiency across numerous sectors. But before we hear from Janne, I want to stress that your support is the heartbeat of my podcast. Every episode is crafted with you in mind, and your generous donations ensure I can keep delivering the content you love. Whether it's the price of a coffee or a more substantial contribution, every bit helps to defray the cost of production. Donate today and be a vital part of the podcast's continued journey to greatness. And for a limited time, donate $100 or more and receive an official Drone Radio Show coffee mug. To donate, go to droneradioshow.com/donate. And if you can, please subscribe to the podcast on your favorite platform and leave a nice review and rating on iTunes. It really helps improve the podcast ranking among the many thousands of active podcasts today. So let's learn how hydrogen-powered airships are scaling up data collection across many industries with Janne Hietala of Kelluu. Let's pick up the interview where I asked Janne to introduce himself.
My name is Janne Hietala. I'm the CEO at Kelluu. Kelluu designs, manufactures, and operates autonomous airships for aerial monitoring.
Janne, tell us about Kelluu. What does the company do?
Well, the first question about the name Kelluu, so it's a Finnish word describing something that is floating. So it's quite descriptive for airships that are literally lighter than air. We can sort of think it in terms of drones and drones being an inspiration for Kelluu, obviously getting things started. With one of the co-founders, Jouni Lintu, who started to think quite deeply about the drones and the drone service business and how to do this properly. And you can think it in a way that humanity has figured out 3 ways to stay in the air, more or less. One is by using a wing profile to generate lift through speed. Second is to use propulsion, either propellers or helicopters or rockets, in a way to counteract gravity. And the third is lighter than air and using lifting gas to counteract gravity. And that's kind of the only way which doesn't require to use energy to stay afloat. Actually, that's the closest you can get to levitation, more or less, in the unmanned aviation. And airships is not like a new concept, obviously. It's being used over 100 years now in different formats. But actually creating an autonomous lighter-than-air drone hasn't been done at this scale yet before. So that's where Kelluu was founded, that how can lighter-than-air be used in unmanned aviation to do aerial monitoring like with drones, but at the industrial scale. So do it properly, like Joni would call in quotes. So that's kind of the origin story with Kelluu, but there are various reasons why it hasn't been done before. So we had the right timing in ways that a lot of these technologies were maturing. So the drone technology in general, all the control platforms that you have, autopilot platforms, hydrogen technology was getting miniaturized for fuel cells as well. The 4G, 5G network connectivity for comms. And in a way, Kelluu was able to jump ahead in a way, a lot of the iterative development cycles that had been going on. And I think, for example, right now, even with multicopter drones, kind of having the autonomous flight beyond visual line of sight and having control over long periods of time is relatively new. It's not being used in wide scale. But due to the nature of lighter-than-air and being a very stable platform, being a very safe platform, while it's flying, and even if you have some sort of technical issue, it still keeps floating passively without external input. So you essentially have a platform that's very suitable, well suited for beyond visual line of sight flights and autonomous flight. But we definitely had to overcome a lot of technical difficulties and different solutions to make small enough airship, to make it light enough airship, to have the control authority within the airship, and to have the energy efficiency within the airship that we can operate in the same conditions as with your typical multicopter drones would.
Let's talk about the airships themselves. They're not quadcopters or fixed-wing drones. They resemble blimps. How large are they, and what are they made of?
Our airships are just under 12 meters long. So it's about 22 cubic meters in volume that we have, a little bit over. So we are at 25 kilo total takeoff mass. So that's kind of the boundary, which us also to operate under the drone regulation. So we have a specific EASA drone regulation, and you need to go through specific certification and regulatory approvals for BV laws. Obviously, the mass and the mass budget is important for constructing lightweight enough airship. So we need to use a lot of the advanced composites in the structures. And you kind of have your blimps that are just balloons, more or less, and you have semi-rigid structure that we have, and you have rigid structures, which are the more traditional Zeppelin-type airships. So we have structures, and we have specific innovations within how do we do pressurization. They usually do pressurization by using balloonets that you need to control the buoyancy as well as the expanding gas depending on temperature. And like going from very low temperatures into higher temperatures, which can happen over long flights, you need to have a specific technologies on board to maintain that internal pressure that the airship maintains its shape. So people do have an impression that it's just a blimp, that it's simple, but you actually have a lot of specific airship and lighter-than-air technology that goes into having a all year round lighter-than-air vehicle. And it does require a lot of innovation as well to be able to downscale from large airships that, there are a lot of different projects around that, but there are not too many small airship projects.
What gas is used to keep them afloat?
That's another innovation that we've done. So we're using hydrogen, and hydrogen has a lot of stereotypes in a way due to the obvious 1937 events that happened in the US. There has been, like in the North America, the ban to use lifting gas, for example, the hydrogen as a lifting gas ever since. But that was actually changed in Europe. So we have approval to use hydrogen as a lifting gas, but it does require process, procedure, and technology to be able to use that safely. So you need to know what you're doing, and you need to have a specific safety procedures in place to be able to use hydrogen as a lifting gas. But the main issue, in a way, is to do with balloonets in general, because balloonet is typically filled with air. And we all know that the concentration or mixture of air and hydrogen creates a flammable combination. And at a certain mixture, it creates an explosive combination. So one definite aspect is to maintain the purity of the hydrogen, which means that it's not actually flammable at that stage.
How much can it lift? What type of payloads can you carry?
So we have a variable payload depending on the kind of the duration. And the payload is a little bit different than you would have in the drones, because typically a drone payload would include, sometimes it includes compute, it includes batteries, it includes GPS. So we've separated, we have everything on board already, and the payloads are typically sensors. But it can be several kilos of payload, including any gimbals that we can have. And we typically also operate with the multi-payload setup. So we can have multiple different payloads. We haven't publicly stated what is the absolute payload, but so far it hasn't been any kind of problem that we can carry all the different sensors required for high resolution imaging.
How does controlling the airship compare to piloting a quadcopter or fixed wing drone?
It is quite different because you're dealing with a vehicle that doesn't really weigh anything. So it does float in the air and it does balance itself out really nicely as well. But then the controls development, because we are using what's called a thrust vector control for the whole thing, that we don't need any control surfaces. We had to develop all the control systems and autopilot in-house for the airship. And there really isn't that much theoretical publications on these autopilot and control systems on this kind of specific solution. Because all the other airships that you do see, they have sort of propulsion attached into the belly, or they have multi-prop systems or different kind of sort of novel control systems, but not really anything that resembles submarine with a single prop like we would have without any control surfaces.
Can it maintain a stationary position even when it's windy?
Yeah, absolutely. So it does work really well with the stationary mode that we have developed as well. And all the flight happens autonomously, so nobody's controlling it during the flight. And we've developed all these different systems for the flight controls and flight operation as well in-house.
What are the best use cases for the airship?
This is kind of the core of the thing, that what we found out that the drones are not really being operated at the industrial scale as a service. So you do have smaller companies that are mainly local companies, and then very specific vertical companies that do inspection of power grid, or they do inspection of oil and gas platforms or things like that. But there are some scaling obstacles with drones that are to do with the range and are to do with how the human operators are involved there. So I think that is the reason why we haven't seen that industrial scale. So what we are essentially doing is we're providing data as a service. So we don't sell the airships themselves, but we operate them and we handle all the regulatory compliance, and we can provide very high quality data due to the operational time and stability of the platform and the payload, having the payload capacity high enough that we can have all the different sensors on board that we need. We don't need multiple flights. And basically, we haven't yet met a customer that we couldn't deliver their data requirement or their area requirement in a single flight. So it can cover very large areas at the high overlap requirement. And then we have developed the data processing pipeline that the customers can actually get the data really quickly. So it already processes that during the flight. And we have the cloud connectivity from the airship already, that all these sort of data transfer starts already happening during the flight. And then the data processing happens with various different methods, and we develop those as well and advance those for very, very large areas. So you basically get this 1 centimeter per pixel resolution and this 3D digital twin that includes also spectral information. So you get information about plant health, your biomass, your ground moisture content, chlorophyll from the water content. So it's almost the question of how can we just simply provide the data to the customer without the customers needing to buy flights. So we have kind of that capability through the airship technology, that it's the best platform for the data collection. So this is about collecting the real world data about the whole environment, including roads, including infrastructure, including forestry, including agriculture and these other areas, that we are able to use the same platform for all these different use cases and then automate really far the data products that get produced from the end. So we can have the actual customer value delivered quick as possible.
Do you primarily serve large customers or small customers?
There's a mix of both. So obviously the larger industrial customers have, let's say, more refined need, and they have more frequent requirement that you need to do something every month, every week, There's more this recurring service type. But we do also work with smaller customers, like forest owners. We have a lot of forests and national parks here in East Finland, for example. So we do feel that it's important also to be able to serve those smaller customers because we can combine those in a single flight. So we don't need to design an operation for one specific customer in mind. It's more that we do have this order book of different types of missions, and some customers wouldn't need to have as high resolution data that we provide. But if we can standardize that at the sort of the highest level, that everything is below 1 centimeter per pixel, and some customers might need only the RGB on 5 pixels per meter, we will collect the data at the highest requirement and then basically deliver that to the customer with the same required cost.
How do customers interact with the company to get services?
It's quite straightforward in a way. We have a basic questions that we ask in the customer engagement, that what is the area, location of the data. We can handle a lot of the kind of technical questions for them or make recommendations when we understand what's the use case, what they're trying to get out. One important thing to keep in mind is that when we have operational areas and we handle all the airspace reservations, we right now operate in East Finland. So this is an area of 35,000 square kilometers where we have the airship range and the bases set up. We do expand this. And this is kind of the expansion strategy that if somebody from, let's say, Canada or Germany orders flights or data now, we wouldn't be able to deliver that yet. But we look for new customers with new kind of use cases, and we basically prioritize where do we set up the next operating base or operating area into, that where do we geographically expand into.
Do you collect a variety of data on a regular basis, or do you fly missions specifically on demand for customers?
Right now, we're mostly doing specifically on demand. So right now, there's much more demand than what we have airships in the fleet. So we're now ramping up the amount of manufacturing that we do in our manufacturing plant here in Reijola, that how many airships per month can we produce. And soon as that sort of capacity is available, then we will start to move also into data first approach and then offering that to various other industries.
How has designing airships specifically for the Finnish climate, with its snow, ice, and high winds, provided advantages or challenges for Kelluu?
It's a really good environment for all different season testing. So if you try to fly multicopters in minus 20 Celsius, where you have very humid air, for example, it's a great recipe for disaster. So these different freezing conditions are something that we have done extensive testing, and we've proven the capability and the flight readiness also for these winter conditions. There are obviously specific climate environments where you have, for example, freezing rain. You wouldn't have real airplanes flying in those weathers as well. So we do need to be mindful of the environmental conditions as well. But the design principles of minimizing moving surfaces, for example, that we don't need any control surfaces, it also means that we don't have any controlled surfaces that will freeze up. So it's a very winter tolerant system that includes also the use of the hydrogen fuel cell for energy production. It does operate all around, and we've been able to develop technologies around that we can have it operate in the freezing conditions.
And how long can the airship stay aloft?
So in the drone comparable conditions, we've done missions over 12 hours. That's not yet the maximum available flight time, but that's something that we can tell that we have done on a regular basis. So single flight in comparable wind conditions, going headwind as well as downwind in both directions, we can operate over 12 hours.
Can you talk about the technological innovations or strategies that allowed Kelluu to achieve a 12-hour flight duration?
It is about energy efficiency by a lot. So you need to consider what is the cost of flight at different speeds. And if you take your typical multicopter, like a larger DJI Matrix multicopter, it needs to use about 1 kilowatt just to stay in the air. It's stationary in the air. It doesn't change that much if it moves or not, but you're spending a lot of energy just there. The airships in general are more than 5 times energy efficient for staying there because they don't need to spend that energy. But then you have a drag and drag optimization. So faster you go, more drag you need to sort of counteract with the propulsion as well. But generally, the control systems that we have developed and improved over the years are very advanced in terms of positional accuracy, flight accuracy, and energy efficiency. So you need to keep these in mind because it's easy to design a blimp that stays in the air and has a good lifting capacity, but you need a lot of energy to counteract the drag. So that also means that will affect your wind tolerance of the lighter than air, that what is the maximum amount of propulsion you're able to generate towards and against the wind. So there's a lot of technology around propulsion, energy production, just generally understanding the airship shape, structures, minimizing drag, materials related to that we basically had to develop in order to make this possible. There is this mass cycle known within the airships that in order to increase payload, you need to increase the volume, even if it sounds a small difference between hydrogen and helium, but helium has a less lift. So the airship would have to be larger, which would mean that you have a larger airship that has more drag, but then you also need to produce more energy as an output. So you're consuming more energy. You need to have more energy storage, which is going to add to the weight. And you have this cycle of mass going upwards. So that is one of the reasons why these airships are very, very large, because you do need to have a lot of energy on board. You need to have a lot of propulsion. And the mass of the system starts to add up. So you end up with 75 or 100 meter long airship that has a very poor the structure to payload ratio, essentially.
How many people does it take to launch the airship?
We have done it with one person. That's not the issue. Typically, we would have a couple persons involved. We follow a lot of the aviation industry standards. How do we conduct operations? So you have similar checklists, preparations, briefings being done like with any other type of flights that you would do. So we follow a lot of those best practices. The ground crew or the mission crew would be involved in those, preparing the airship, the mission, checking on the weather conditions, considering energy consumption requirements, the nature of the missions, preparatory of the payloads, and all these other elements before the flight actually starts. So we fine-tune that process as well. The ship up or ship down can be done with just a single person, but for more like a convenience reasons, it's easier to do with two people. But we can, with lighter than air, automate a lot of these procedures much further than with the drones, because it's a very stable platform. And the control accuracy that we have, we can pretty much land it on a dime if needed.
Monitoring transport and electricity infrastructure in remote areas is crucial. How do Kelluu airships specifically address the challenges faced in such regions?
I think that is really the unique aspect of the lighter than air and the range of the airships, that it's already designed. I would say that it's much closer to unmanned aviation as people would imagine unmanned aviation to be than with the multicopter drones or the fixed wing drones because of the limited range. And most of the multicopter drones and fixed wings are designed to be used and controlled over radio frequencies or radio controllers. So we are basically controlling the airships through the cloud if needed and the cloud connectivity. There's a specific technologies being matured there as well that we can then leverage also in those areas where we don't necessarily have the ground infrastructure for communication with the airship. It is really cool to see. You go to a remote location like we have the National Park Gully, and you have a high hill where you can see all the landscape. We've done several missions during this summer in that area, and you can just see the airship coming over the lakes and the islands really, really serenely, and it's very quiet. And it sort of floats in the air like a fish or weird-looking submarine with this glimmer. With the drones, you get almost people a little bit annoyed these days. It's like a flying lawnmower, makes this buzzing sound. But there is this aspect of beautiful flight aesthetics with the airships. There's a little bit uncanny feeling for people that it's not supposed to fly like that, because it is literally floating and resembling like you would have a submarine in the water or fish in the water and just floats around very gently. And people don't usually even notice it until it's kind of top of their head, making turns or increasing propulsion. So it's very, very quiet. The people's reactions for these extended flights, a lot of people have obviously seen it, is generally very, very positive. They will be kind of excited that I saw an airship now flying, and it's this local company that produces this. So it's almost like an experience for people, which is great feedback for us.
Does the pilot operator monitor the mission visually or remotely?
They are monitoring completely remotely. So we can do operations from our operating center that are thousands of kilometers away.
Given your experience, where do you see the future of hydrogen energy in the unmanned aerial industry heading?
I think its role will be crucial because it adds complexity into the system as a whole. So if you have a battery pack and you have an electric motor, there's a certain size that it starts to make sense in multicopters or fixed wing airplanes or passenger airplanes. I think there's still ways to go in terms of increasing the energy conversion efficiency within the fuel cells and the lifetime of the fuel cells, obviously. It's similar development as with electric cars in general, that you get increases into the range and performance. But I think the availability of hydrogen compared to helium, for example, or applicability in terms of energy density, as opposed to you have hybrid drones these days that use combustion engines, or you have pure electricity, it will be very difficult to compete with the mass versus energy budget that you have available with hydrogen. So it's a very kind of emerging technology, and you have a lot of different applications for hydrogen in unmanned aviation. But generally, the availability and the price of hydrogen is really good. And then you start to have these green hydrogen investments that it's net zero, it's carbon neutral to get and use hydrogen. And we just go to a local market and we get it shipped right now in bottles, and it's being delivered to our door, and we're paying probably 10 times more than the market price, but still the unit cost of flight hours is ridiculously low in terms of the cost of hydrogen. So it's a really beautiful field.
Do you consider Kelluu being a consumer of hydrogen technology, or is it an innovator and contributor to its evolution?
I think there are elements of both. Ultimately, the customers don't really care what is the tool, what is the gadget or the drone that you use to collect the data. And I think what we can demonstrate is that with the technology that we have, we can just make the data at the high resolution available into much broader scale and into much broader use cases where we can lower the cost of the data significantly, almost by an order of magnitude. So it can be used in various different areas that it wasn't feasible just with the multicopters or the traditional drones. So it's almost like the hydrogen and how we construct, and if we use airships or if we would have a drone that just flies 18 hours, that doesn't matter as much long as we are able to deliver the data at the fastest possible to our customers and provide it at the scale. But that hasn't been possible in the past at the scale what we're doing already today, that we're able to push a lot of the innovation on the data side as well, creating this digital twin of the environment, including the multispectral data. It's been much more experimental, like pilot project and small areas. But to have that available at the scale, it's filling this layer that if you have satellites, you have airplanes collecting in aerial monitoring, you have been missing that high resolution layer that you're able to collect operating under the clouds autonomously. So it's kind of having the right technology and right tool to be able to do that. And through the physics, it kind of makes a lot of sense that we would use lighter than air technology to do that. But kind of there you have a lot of these smaller technical challenges that you have to overcome in order to create an autonomous airship that's able to be small enough to be able to operate under the drone regulation and have this level of autonomy. So I don't think this would have been possible 5 years ago. It is definitely possible now. And now it's more about ramping up operational scale and bringing it into the market fast as possible, so the societies can benefit from that data that we can produce.
What sort of feedback are you getting from your customers?
A lot of the aerial monitoring has heavily relied on LiDAR. So the laser scanning and using airplanes and helicopters to be able to do that. And through the development of processing technology and photogrammetry, we don't really need that. So you are able to get as dense point clouds, and you get even better accuracy and results with just purely taking individual photos and stitching them together into a 3D model. And there's tons of advancement happening in that space using neural models as well. So just showing the data that what we have done, examples of that, the feedback is quite often the amazement that, wow, you are able to get at this resolution and these large areas in a single flight with the cost they are used to seeing from other drone operators from the market, but the quality is so much better that they've before seen. So it's kind of opening eyes through that. This is actually something they can use on a daily basis, planning operations, planning land use, doing inspections, doing forest management. But it needs a little bit of wake up because of these old traditions that exist in the industry that point clouds are usually 1 point or 5 points per square meter. And the tools and the methods for analyzing forest and forest inventory, for example, have been developed using that sparse data from airplanes and from other scanning methods. So just the general availability. And I think there's a lot of healthy suspicion as well when it comes to drone industry. So a lot of people are just in amazement when they come physically here at the factory or in one of our ground bases and see the airship to fly. And when they sort of follow it for a while, they all go like, well, this makes a lot of sense, actually, now that they see it flying. Just doing a PowerPoint or explaining that, well, we have a thing that can fly 18 hours. It doesn't kind of mean anything in general because you have a lot of different other drones. But kind of seeing the performance in real life is a real eye-opener for a lot of people.
Now, Kelluu also manufactures its airships. Where is the facility located?
So it's located here in East Finland, nearby Joensuu. We have, I think it's now 900 square meters or close to 1,000 square meters of factory area where we produce. We prepare all the ground equipment as well. So the storage facilities, whatever is needed in a new ground base. So it's not just about airships, but it's all the infrastructure that's required for the airship operations and new ground-based setups are done here in Reijola.
Can you share some insights into the scale, the capacity, and any plans for expansion?
I cannot go into very specifics about lead times and capacities right now, but we do look to double the manufacturing capacity before end of the year. So that's kind of the goal that we've had in the mind. And we want to increase the manufacturing capacity over every 6 months when we go forward. And that's definitely doable. So a lot of the technologies and a lot of the processes are improved as part of the manufacturing. We do a lot of that right now in-house, but we look to also get subcontractors involved that we can then outsource some of the components manufacturing in there. It's an interesting challenge when you're improving manufacturing, you're manufacturing at the same time, and you're doing development. There's a lot of inspiration we're taking from SpaceX, for example, and how they built and iterated their launch capacity. You need to have a lot of high cadence, and we have a internal target that we all sort of aim towards that we think is a significant number of flight hours. And everybody's sort of working towards that. The operations wants to operate every possible day that they have a crew available and airships available, as many airships as possible. We have manufacturing that is aimed to ramp up the manufacturing capacity as fast as possible. We have R&D that looks to drive the performance up of the airship, and the software team that's looking to process all the data that comes from the airship. So it's almost like an internal, very positive race toward a single goal that basically means that how broadly we can have this technology available for end customers. But at the same time, it's definitely not the way that if you compare SpaceX and Boeing in their crew programs, for example, of how NASA operates currently, it's not this slow and steady, careful, iterative cycle of designing something for 3-4 years and then creating one of them. It's learning by doing in a lot of ways. So a lot of the flight hours mean that we're going to find out that which components fail at which stage quite fast as possible, it's then the feedback to improving both manufacturing and design of these components. So this kind of flying as much as possible is our core of the company that is taking us forward the fastest possible way as well.
Well, you're also still a startup company where everything is still ramping up, so to speak. So you have a lot of things going on.
I think that's the most fun part of being in a company like this and driving the growth of the business. There are so many details, and you're constantly working with manufacturing operations, the data and the software technology, autonomy and controls. You have these different teams working really, really intensively together in a single purpose, single goal. Because we feel that this technology can do a lot of good and unlock a lot of solutions to the environmental challenges, climate change challenges, improving safety around our societies as well. And it's important that we do that quickly. There's sort of mission-driven mentality within the company altogether, and this attracts people around the mission. So we've been able to get some brilliant talent that's now doing these things and making these things reality. Personally, I enjoy it a lot. I know a lot of people would want to be in this steady looking at one part and optimizing the one part of the system, but it's almost like we are doing everything at once. And it is challenging, but doing challenging things also motivates a lot of people.
Building on that, why did you start a company with this technology?
Our founder, Jouni Lintu, who we call the father of the airship, he likes to think about different things very deeply. Let's put it this way. And when in the 2016, roughly that area, the drones were getting mainstream, that you go to hardware store or your electronics store and buy one and start doing service business, it was that sort of moment that he started to think that, well, how could we do this properly? How do we do this in an industrial scale? And there's always a great story with founding a company. And I use it as a phrase that all the good companies are founded in garage, some way or another. But the really brilliant companies are founded in a barn. So this was founded, the first hangar was in a secret location in East Finland in a barn, which was hydrogen safe space because even the roof was leaking. So you had a natural way for hydrogen to evaporate. And the guys did a lot of prototypes and testing back then. Average flight time, what I've heard back then, was between 6 and 60 seconds before disaster. So it definitely took a visionary mind and a lot of persistence, or a lot of sisu in Finnish, to kind of create a working prototype and working airship to see that, well, this is something that will end up revolutionizing aerial monitoring. And it's really, really rewarding to see the progress of the airships and the airship performance that we have today. Then seeing some of the old videos and pictures of the guys going in a forest with the very small radio-controlled airship that fails in 6 seconds, how this has come to reality through that persistence over the years. So it's definitely required a lot of innovation and persistence.
When did you formally launch the company?
The idea was in 2016, and the company was founded in 2018. And now the factory where we are was set up in 2021. And that was kind of the first years where we started to build the larger prototypes that then turned into the production models that we have now, what we call these under 12 meters. So we've gone gradually from smaller versions of the airship and just operating those a lot and gaining experience in different conditions, different environmental conditions during winter and different seasons at different types of missions. So there has been a lot of iteration and different versions that we have done before hitting this kind of production version that we have now.
When did you know that the idea was really going to work?
That was a year ago, basically, when the first over 12-hour missions were done. And that was kind of the point that flying for 12 hours is good enough. We don't really need to push that much further. And we started then to scale. We made the decision that we're now going to set up a specific team for manufacturing, specific team for operations, and we're going to start hiring people and scaling the business. So that was definitely the milestone that we found out. And we did a lot of autopilot development or the control system development at the stage as well. And kind of the state of the art with the previous versions of the autopilot wasn't good enough for very accurate flying. And to be able to get the control accuracy down, if you think about a cube of 50 centimeters by 50 centimeters by 50 centimeters up to 1 meter, that we're able to get the flight control accuracy of position hold at different environments under that. So that kind of very accurate flying is required, obviously, for mapping, and then to have a precise control with the autopilot in different conditions. And generally, the operation in high winds, it's not trivial with lighter than air. So you need to really be conscious of the environment and weather simulation and weather modeling when you're planning the flights. So there has been already a lot of development, but now over the last 16, 18 months, we've sort of sped up and pushed the pedal to the floor in a lot of these areas, ramping up this into commercial operations.
What advice would you give to other entrepreneurs?
I have personal background of being an entrepreneur all my life, over 20 years. A lot of the startup entrepreneurs, they are relatively young, and I think there's a benefit to that as well. But there's another sort of benefit of bringing into the team more experienced people as well that have done it before as well. I think for me personally, it's definitely a confidence booster that I've grown international business before. I have a natural curiosity for the technology as well. So you need to have a right mix of people within the core team and the founding team of the company. And if there's sort of an area that young entrepreneurs feel that they're not necessarily experts, they shouldn't be afraid of going and sort of getting the right talent into the team and we don't know what we don't know. So in a lot of times, bringing in experience from other industries and mixing them together will just give you a better insight into how to do and how to scale the business going forward. So the previous business that I spent time with and we grew over a period of 15 years, we basically bootstrapped the business. So it's a very sort of tedious process of generating cash that you invest into the product and not to get investors involved. So you basically add the value yourself and you maintain control of the business and things like that. So there are benefits of that, but there's also a lot of grind. So thinking that what is the type of the business that do you need investors? Is there an accelerator of taking the technology to market by working with good investors that can add both the resources as well as other contributions into the business through experience and networks? But not every business needs that necessarily. So it's kind of finding the optimal balance with the resources, time to market, the technology maturity, and the talent that you need to have in the business, that how can you take the company forward?
What's next for Kelluu?
It's always fascinating when you're almost making aviation history in a monthly basis by kind of adding flight time or autonomy or this specific type of data missions, flying from multiple ground bases as well. I think what we look forward to is having the largest airship fleet in the world. I think Goodyear has 4 operational airships right now, so we're going to exceed that quite quickly now with this pace that we're going. I think there's going to be operations in multiple countries that we're going to do, and we're going to start covering very large areas in Finland and in other countries in Northern Europe as well. So there's the element of operations, scaling the operations and making it more widely available. But then there's a lot of innovation and breakthroughs that are going to come through the data that we're able to collect. This high resolution digital twin of the environment, it's going to open a lot of eyes. I think there are only a couple of companies in the world that do invest into this at large scale. Google being one, they just launched the immersive city views where they use these neural radiance fields, for example, for creating a very realistic model of the cities. But even they need to fly with something. So using this capability that we have to collect the high resolution data, I think it's going to be very interesting how that's going to be used in metaverse, combined with virtual reality, transform some of these industries like in forestry, agriculture, infrastructure maintenance. But I think it's going to be very fun to see how widely this kind of data will be adopted. And we don't expect to be here alone. So there will be a lot of other companies doing something similar in the upcoming years. That's what excites me personally to see and go forward.
Is there anything that we missed that we should talk about?
We are constantly hiring people. So we are looking for the best people, obviously, in different kind of roles, whether that's to do with the engineering roles, technician roles, operational drones. So we are hiring and training our own operators for the airships as well. And there's a nice benefit of coming and working to Kelluu, because at every title you have airship in it. So your airship engineer, your airship operator and a pilot, airship technician. And I don't think there are too many companies, there are a handful of companies in the world that can offer the same. But it's a really brilliant team that we have here. And even for some people internationally, Finland might be a little bit distant, but we have a lot of beautiful nature here and outdoors opportunities. So that pulls a lot of people to think about Finland as an option to work as well. But we are open for international talent, and our open positions can be found on the Career website as well. So I think that's kind of the message that I want to convey as well, that there's companies like this in Finland that provide opportunities, unmanned aviation, and making the aviation history and to be part of that.
And for my final question, Janne, what message would you like to leave regarding the future of the drone industry?
I think the drone industry will face a lot of challenges, and it's kind of pushing into manned aviation and controlled airspace. I don't think that's yet being solved. So if we can accelerate the regulation to be more acceptable of unmanned aviation, just define the right kind of safety procedures and transponders or communication of the location and direction and avoidance, that what we need to do between unmanned aviation and manned aviation, that would remove a lot of the obstacles for the innovation. Because I think eventually we need to have similarly with cars, you will have autonomously driving cars and autonomy with driving vehicles and mobility. You will have autonomy in aviation as well. So kind of allowing that from the drone industry and push that while maintaining safety. How can we do that fastest and the safest possible way?
That's it for episode 408 of the Drone Radio Show. I hope you enjoyed hearing from Janne Hietala of Kelluu. I want to thank Janne for taking the time to speak with me. If you want to learn more about Kelluu or want to connect with Janne, check out the webpage at kelluu.com. And Kelluu is spelled Kelluu. If you like the Drone Radio Show, then please subscribe and share. Write a glowing review on iTunes. And if you're able, donate to keep the podcast going. Go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.